Now the program can start. I request Madam can take over the session.
Thank you. Good morning and warm welcome to all the participants across nation for today's webinar series on Top 7. Today our founder cum principal, Dr.PSS.Srinivasan sir is going to present the topic Insights on Quality Research. Welcome you sir. I would
Yeah,
like to welcome Dr.
happy in
Stephen.
joining, madam.
Okay, sir. Thank you. I would like to welcome Dr. Stephen, Director of KBSS, and Dr. Visakha Vail, Vice Principal of our institution, Dr. Thangavel, sir, Director for Center for Career Development and Training, and Dr. Rajendran, Director for AAA and PAT. Welcome you, sirs. Next, I'm happy in welcoming my colleague, Dr. Muniraj, who is coordinating this webinar series at Research Forum. And I would like to welcome Muniraj and heads of various departments, faculty friends of KOT, students of KOT inside and outside of our KOT campus. So you all know the things why KOT is keen on promoting research activities since the flavor rises from a KOT trust. Our institution is promoted by academicians in engineering, entrepreneurs, and they have an experience in research with national and international exposure. So our today's speaker, Dr. PSS sir, is nurtured a seed at Research Forum. He has kindled all the minds of KOTians towards Research Forum during that inception of that institution. So we are arranging these kind of activities for the publics, those who are going to be benefit out of not only from today's program, in the series of programs under a Research Forum umbrella. Since motto behind our trust is to provide quality education to the society. So quality in providing research scholar is also our motto behind our institution. At this moment, it's a privilege for me to share that as KOT reached top 60 institutions at an year of 2016 itself, as we have kept as a roadmap, at 2025 alone, we plan to bring our institution at as top 10. So with the support of all our stakeholders of KOT, we expect that we will reach top 100 institutions in our nation at 2030 and top 500 institutions across world at 2035. So you all came to know the things. Our institution has existed to provide a service to the public based on the quality of an education. So we have framed our mission of our institution is to generate new knowledge by engaging our undergraduate, postgraduate, and doctoral students in cutting-edge research. To enhance such cutting-edge research at KOT, in all our departments, one center of excellence have been existed to carry out these research activities. Since our mission is to pursue global standards of excellence in all our endeavors, namely teaching and research, particularly in consultancy activities. So with that facilities which was existed so far, we have received grants so far at KOT by means of all different department technical clubs. 1 crore plus amount has been received from different funding agencies. I'm proud to say that things. I'm on the principal investigator for that research. Center for Medical Imaging facility has been set up in our institution as a first principal investigator for this research forum related activities. Along with that ACT RPS fund, through which an incubator from MSME Delhi, we received a fund to promote research activities for our students, and they are capable enough to promote their findings as a product through that centers. As the students are actively participated in national and international contests by the unique features of a KOT, namely makeup product. As we have received a fund of 1 crore by means of what? Our institution nurtured innovation ecosystems and therein cultivating research activities for faculty and students. Our institution, our tests were promoted 9 different industry-linked laboratories and 6 centers of excellences at our institutions to enhance that cutting-edge research activities. Through this industry-supported laboratories, the faculty and students and industry partners collaborated with us. Together, we have solved so many real-time problems, and we are going to build the workforce for the future, and surely we are going to develop an innovative solutions which is not solved at a moment of COVID-19 also. And these industry-linked collaborative center of excellences provides a platform for our students to enhance their skills by learning by doing. Learning by doing is an only unique features of our KOT. Therein we are succeed up to this level. Because of these, we have received a fund of around 1 crore, even a child of our institution age. And I'm happy to share that 2 of our departments, electronics and communication engineering and mechanical engineering, already have research center. We were applied for electrical and electronics engineering department also for doctoral program. Soon we are going to receive the doctoral program in that week. So all these possibilities of research, one way or other way, we are focusing on research. You all came to know that Knowledge Institute of Technology is for placement. It doesn't mean for that placement. There is a 50% part is wherein the students and faculty members and the publics, they can concentrate on research. In what way our department of ECE has enhance all sort of skills of our students, including me, by means of this research is, as by learning by doing concept. We have received 3 major consultancy work from the renowned companies at Coimbatore for to solve an real-time problem like active noise cancellation for the domestic devices which are used in day-to-day life. For example, the mixer and grinder noise. We all came to know, either both of the spouses might have know the disturbances which was created while you are grinding the things in that way. As we are proud enough to support consultancy to solve those, removing those noises both in a hardware mechanism and software mechanism, that's a special feature of electronics and communication engineering. And we have and set up and separate research and development laboratory. In spite of serious effort taken by the trust and institution with the fund, our institution students has taken part national contests like Texas Instruments India Innovation Challenge contest every year. Because of their active participation across nation, we will stand 4th place at nation. Therein we were generated around 32 lakhs of funds from Texas Instruments to set up an Texas Instruments Innovation Laboratory at KOT. Therein our students finds so many findings. Therein they were submitted those articles to an renowned conferences and renowned journals. We were also published relatively referred journals and conferences by our undergraduate students itself. And 9 of our faculty is pursuing PhD in different areas of research, namely biomedical, sensor networks, and solving all sort of real-time problems. Myself, I'm proud to be stated at this juncture. I'm an active reviver for an IEEE Journal of Biomedical and Imaging, and 10 more journals, myself acting as an active reviver. Likewise, today's speaker is also an active reviver for an renowned conferences and journals. These are a regular cultivated habit of our persons, those who are working at an KOT as a senior most, and the teams also supported there. And most of that works which was published by as a team are student of undergraduate, postgraduate, doctoral programs. Along with that, research scholar and guide are being supported and made our institution to reach a good H index. And we also expecting the same thing to be reach over across nation, whatever the knowledge which we have gained. We are interested to share by means of through this webinar series. Once again, I'll welcome all the participants. You can take away much more insights today from our inspiring personality of our KOT, Dr. PSS. Is going to present a topic today about insights of quality research to all of us. Today, we are also eagerly waiting to know what's the new thing he is going to share today with us, in what way which are going to enhance our research to do much more better. So, on behalf of our KOTians and my own behalf, and welcome you all the participants once again for today's webinar series. Thank you for the opportunity given by our principal sir and our management for me. Thank you. Next, over to Sachidanandam to introduce our today's guest. Thank you.
Thank you, madam. Good morning, everyone. I take immense pleasure in introducing today's resource person, Dr. P.S.S.Srinivasan, sir. He is an edupreneur, founder of Knowledge Institute of Technology Trust, Knowledge Institute of Technology, Knowledge Business School, and principal of Knowledge Institute of Technology, Salem. He is a visionary. He wants to make this institution one among top 500 institutions in the world by 2035. So he got this vision in the year 2009, right from the inception of this institution. He has visited 13 universities in various countries like Canada, UK, Hong Kong, China, Taiwan, and Singapore, which are listed in the top 100 universities in the world rankings. On seeing his academic background, he completed his diploma in mechanical engineering with gold medal in Tyagaraja Polytechnic College, Salem in the year 1984. He got his undergraduation in mechanical engineering from Congo Engineering College under Bardhian University in the year 1988. He ranked in the university. He got his post-graduation M.Tech in IIT Bombay during the year 1990 with gold medal in thermal and fluid engineering. He completed his doctorate in mechanical engineering under Bardhian University in the year 2002. His area of interests are being heat and mass transfer, computation fluid dynamics, refrigeration and air conditioning, solar passive design of buildings, and many more. His work experience, or he started his career in Congo Engineering College as assistant professor in the year 1990. He has been promoted as head of the Department of Mechanical Engineering in Congo Engineering College during the year 2002. Till 2005, he was heading the Department of Mechanical Engineering in Congo Engineering College. From the year 2005 to 2009, he has been working as principal of K.S. Rangasamy College of Technology, Tiruchengood, and from 2009, he has founded this renowned institution, Knowledge Institute of Technology, and he is the principal right now for this institution. He has over 30 years of academic experience with 19 years in research. He has published more than 60 international journals, 52 national journals, and he has participated and presented papers in international conferences, national conferences, and he has published 3 books. He's an university supervisor, or recognized supervisor. He has guided 14 PhD scholars who has already completed, and currently he is supervising 3 scholars under an university. Coming to awards and recognition, he has received Best Principal Award in the year 2016 at national level from ISTE New Delhi. Received Distinguished Alumnus Awards from Congo Engineering College and Tyagaraja Polytechnic College, and received Best Faculty Award twice from Congo Engineering College during his tenure in Congo Engineering College. He is a member in professional bodies like ISTE, he is a life member, New Delhi, life member in National Society of Fluid Mechanics and Fluid Power, Bombay, life member in Society of Heat and Mass Transfer, Chennai, life member in Institution of Engineers, India, member of CIA Salem chapter, MMA Salem section, and Salem Pondicherry Productivity Council. So with this great personality, so he is here to enlighten us in the area of research how we can do research, and also without any knowledge of research, you can understand how you can start from the scratch. Thank you, sir. Thanks for this opportunity. Over to ECHOD, ma'am.
Thank you, Sachidananda. Now over to Principal Sir to take over today's session.
Thank you, madam, for a nice welcome, and thanks to Sachidanandam for few words on me. So today, there are about some 300 participants in the Zoom, and a few maybe on the YouTube. I'm very happy to see all of you. In addition to me, we have three more participants: Mr. Venkateswaran of KSR Polytechnic College, Tiruchengodu; Mr. Vignesh from PSG College of Technology; Mr. Srimad from Annamalai University. So they will be, whenever I raise a question on behalf of you, they will give few answers so that we can make the session interesting. Dear faculty friends, tomorrow in the next talk, my research journey, I will explain in detail how you can start a research, my personal story, and what will happen in between, how many setbacks will come, and how to overcome those setbacks and all. But today it's of purely technical part, how to do a quality research. You need not know anything. You have simply interest, hard work, 5 hours per week. You are ready to devote time. You have interest, and you have a perseverance, because research needs 3 to 5 years of effort. Perseverance. If you have these three things, you can do beautiful research. You can get PhD. You can guide students. You can make many people to get PhDs. So that is objective. See, when I took over as the principal of KSRCT in the year 2005, there are about many areas to improve. I have chosen 3 areas. One is improving the academic results, and another is improving the placements. Third one is faculty development and making the people, faculty to register for research and pursue research. 80-30, 60-30-10, there is a rule for time management. So 60, we have to do all your routine in 50% of the time. Suppose I am working for 8 hours a day, I have to complete all my routine in 4 hours a day. Remaining 4 hours, I have to devote for 3 major tasks. That too, that 4 hours, if we make it as 100% of the time, then 60% to task 1, 30% to task 2, 30% to task 3. We run it for 1 year, 2 years, that will significantly improve. This is one of the great learning lessons I have learned when I was at HOD. I have applied in my earlier institution. So 2 years, after 2 years, 1 year I shifted this focus. I removed this results because it has come automatically. So placements, faculty development and research. And then the third component is, sir, some of you has to mute. So the third component is improving the research infrastructure. So I tell you, when I was into that institute, I was the 32nd man with PhD into the institute out of 350 faculty strength. And when I left after 4 years, the strength was around 130. And about 250 people during my tenure registered for PhD. All 250 completed in 4 to 5 years. And all have invited me for the Viva, and all have thanked me after the Viva. One of the main part they thanked is English writing quality was reasonably poor to many of them. So I arranged one external resource person from Coimbatore, and hands-on practice for 3 weeks, 21 days, full day for improving English. For that particular activity, almost 200 out of this 250 have thanked me. Why I am telling all these things is that don't think that research is something very tough. It is like going to a tea stall and ordering a tea and taking a tea. Okay, if you do this continuously for 3 years, 5 days a week, then you will get PhD. So that extent, if you follow what I say today and tomorrow, in the next talk, the next Thursday, I assure you that you will have a great thing. So let me go into the presentation now. Sir, are you able to see my screen?
Yes, sir.
Okay.
So presentation mode போட்டுருங்க sir.
Yeah, coming. Sir, are you able to see my slides?
Yes, sir.
Okay. Sir, if you have any doubt, don't raise the hand now. I will take it up at the end. Only the 3 people who agreed for interactive mode will interact with me, and that too for my questions. So let us take another 45 minutes and complete my talk. So today, we are talking on this particular topic, insights into on quality research. The word quality is key here, and because without quality today we cannot survive. So in this presentation, what you will learn. So there are few talks that are already given in this area, but as a prelude, it is required. So research and its approaches. What is research and various approaches for doing research? Why should we do research? And so having decided, known this, how to identify a research problem. So I will take a one research paper. One of my research scholar, Mr. Gauri Shankar, is doing PhD under me. Recently registered, completed the course or about to start. I've taken one of the research paper from him, and I have with that as an example, I will be explaining these 3 parts: how to identify a research problem, and it was an experimental simulation for how that is being executed in reality. So that will give a real feel of how we can do. And main part, by all these things, you will generate some kind of results. So how to present results and discuss, that is a heart of any research. So that will be again discussed. And then this requires a subject fundamental. So it's related to heat transfer, but don't think other branches don't afraid. This I don't go into anything into the deep into the subjects. In the subject, it is like this: how it can be manipulated to coin so many research. So linking the subject fundamental, how you can generate a variety of research problem out of this one research paper. This is where how to identify a research problem. Many one faces difficulty. So with that, I will close today. In my second talk, so while doing all these things, what are the various difficulties you may encounter? What kind of physical and friendship, research circle environment you should, if you create, and how to do time management by balancing our regular college work and this. With all these things, we can able to complete the research in 3 to 4 years. So now let me go into real component. What is research? Dear friends, research, the word itself, split into 2: read plus search. So search, so how you are searching existing problem, searching an existing problem and trying to design a new system, all from some loss or performance enhancements. This is researching, that is applied research. Sometimes some new phenomena we may notice. One researcher noticed, many researchers will extensively start doing research. So finally, that becomes a generalized truth or law. So our world phenomena for a new truth. So this is called normally a basic research. So whether I want to be in the basic research category or applied research category, you have to decide. Second, we are all engineer. From a engineering perspective, we have something called system. So within the system, there are so many components. Then every component will have one or more processes. So that is how it is. Every process has got a scientific law behind it. So that is how. Say for example, if you take a thermal power plant or where coal is being burned and using steam as a working fluid, work is being generated, that is converted to electricity, that is being distributed to all of us. If you analyze the entire power plant, then it is a system level problem. If you analyze the power plant has got four major components, that is boiler, turbine, condenser, and then pump. So if you take any one such component, that become a component level problem. Or in the boiler, there will be one particular process that are happening, converting water into high pressure steam. So how that happens, how to improve that? If you go to that level, that becomes a process level. So according to which type of thing you choose, if you choose a process level or a component system level, the method of solution here will vary. So that is why, again, you have to identify, I want to see an entire system. Suppose you are doing a social research, say for example, what is a mood of people in the upcoming election? If you take India as a country, then that becomes a system level. Okay, if you take one district, that will become a component level. If you take one village, 5 sample villages, if this 5 sample villages behavior will be the 95% of the people will, if you project it, that becomes a process level. Everywhere it applies. So now, so having identified whether basic research or applied research, now whether you are going to do at a process level or a component level or the overall system level. So if you complete these two, then comes the method of solution. So depending on this combination, this will vary, but in general, there are three major areas. One is create an experimental facility and generate data and analyze the data and come to some conclusions. Or otherwise, for this is mostly analytical solution will apply to process level, and experimental solutions will be applied to a system level or a component level. So generate governing equations, some kind of partial differential equations, and then using some mathematical techniques, you solve it. This becomes an analytical solution. It's purely applying the principles of mathematics. Second is called simulation. So if you do a process level simulation, that becomes a computation fluid dynamics or finite element analysis, like that we do in mechanical engineering. Similarly, every branch has got their own packages. Or if you do a component level or a system level, mostly we call it as a modeling and simulation approach. So here, some basic physical phenomena we mathematically model and do some analysis. Second, this is for social research, for social science kind of areas where we do some empirical research. It means, then I was telling about how the people, to which party the people will vote in the upcoming election. I am introducing a new shampoo, how people will buy, because there is these are all perception based. So here this is called hypothesis testing using certain statistical tools. If this is going to be like this, it will happen like this. This is a proposal. This is called hypothesis. So by collecting the data using certain tools, we have to, using some statistical method, we have to prove or disprove the hypothesis. That's how the research goes. For this, after two of my talks, I have arranged one professor, Dr. Murugesan from Bangalore. He has given two talks to our MBA students, a very excellent talk. So I have arranged him for one talk. He will elaborate more on this area. Mostly we don't do much in empirical research in engineering, but still the areas like heat transfer, there is a different kind of empirical research is being done. I will highlight that in my next talk. Then all these things are analysis part, but finally when you want to make anything as a product, you have to manufacture. So you have to finalize certain dimensions. So it means you have to optimize. Only under optimum conditions, the best performance will be able. How to optimize? So this is again a big area of research. There are traditional optimization techniques are there for about up to 1970s or 80s. Then after 1980s, the new things by observing nature, non-traditional optimization techniques have evolved. like genetic algorithms, simulated annealing, and colony optimization, artificial neural networks, and so on. So these areas, again, I have arranged Dr. Parthiban from NIT Trichy. He is good at it. So these are all the lectures that will be added in future. So I will be mostly covering on 90% this area and 10% of this area. That this 10% only in the next talk. So dear friends, because whether basic research or applied research, or process level, component level, or system level, then what kind of research solution method? But this solution method varies depending on what is the type of phenomena. So whatever happens in the world, either a living system or a non-living system or a man-created system or anything, you can classify into two major categories. One is called continuum phenomena, another one is called discrete phenomena. So for every phenomena, there is a set of mathematics our mathematical friends have developed. Those using those mathematical techniques, we model this phenomena, physical phenomena, or a physical system into a set of mathematical equations. Whatever inputs you give it to the physical system, same inputs if you give to this mathematical equation model, same kind of output it will give with 95% accuracy at least. If that is the case, then our model is correct. Then using this mathematical model, we will do a lot of analysis and design certain similar kind of new systems. So that is what is a process every engineer is doing in every branch of engineering. Only the field varies, but the process remains the same. This is called applied research to develop certain new things. So for this, you need what kind of mathematical techniques you have to use. So that is where this particular slide comes in. So you have to identify whether the phenomena is a continuum phenomena or the problem or aspect or a particular part you are analyzing belongs to continuum category or discrete category. What is this continuum? As said, within the system, there exists some kind of continuity. The phenomena can be described by mostly calculus, partial differential equations. The method of solution naturally goes into either closed form solution or a finite difference, finite volume, finite similar such approaches. Or sometimes we in other branches like electrical engineering, they use extensively Laplace transforms. For signal conditioning in ECE, they use Fourier series or fast Fourier transforms. They are all various solution techniques. So I being mechanical engineer, I am familiar with these techniques. That's why I listed. It's not a thing. There are n number of such things. Say for example, if I want to analyze the temperature distribution, this is room one wall, this another wall. I am putting an x-axis, x1, and I want to plot. You will put a continuous curve. So that is why that is called continuum phenomena. Similarly, a stress distribution in a beam. It's a beam. You are applying a load, and there will be some deflection. There will be some internal stress. So it is a continuous because there is a material continuity. Discrete phenomena means every entity is separate. There is no connection between one entity to another entity. Okay. So wherein we use statistical techniques. Example, literacy level of people in a village. If you manufacturing industry, defective components during manufacturing. Or say if this is a classical example I always used to tell. See, if you want to analyze or improve the performance of a thermal power plant, say nearly located in Mettur thermal power plant, then you will be using this as a continuum phenomenon because within the system, water comes, steam is continuously circulating. So there is a continuity exists between the entire cycle of operations. But if you want to analyze, you have taken 10 such thermal power plants, one located at Mettur, another located at Chennai, another located in Andhra Pradesh, another located in Maharashtra. What is the efficiency or performance of each power plant? How does it compare? So that one may be using steam, another may be using something else. There are a lot of variations. So it means that becomes a discrete category. Another classical example is if you want to compare the mathematics marks of 50 students in a class, that becomes a discrete phenomenon. There is no connection between mathematics marks scored by student A with student B or student C. On the contrary, what is the mathematics mark my grandfather has got? What is the mathematics marks my father has got? What I am getting, what my son will get. There is a genetic continuity. This becomes a continuum problem. But if you compare 50 different students, that becomes a discrete problem. So depending on that, the method of solution, that mathematical modeling approach you use will vary. So these are all very essentials. Okay. Are you clear? So what is research? Basic research or applied research? Then you once in any category, there is a process level, component level, system level. Then the method of solution either using certain continuum system modeling, or this is a discrete system modeling, or either discrete or analog, this continuum. Always we like to optimize something. So what is discrete? What is continuous? This is how we said. So let me put a pass here. Now let me move on to the three participants who are ready to make some answers. So Venkatesh Saran, can
Sir,
you? Yeah. So why should we do research? Nam here research panan. Why should we do research?
sir, do research means do some new component to the market and the
Okay.
engineering. தமிழ்லயே சொல்லிருந்தேன் சார். சார் புதுசா ஒரு காம்பனண்ட் வந்து தயாரிக்கணும். அதை வந்து நாம வந்து அந்த காம்பனண்ட் வந்து தயாரிக்கிறதுனால என்ன இப்ப இருக்கிற பிரச்சனைகளை வந்து நாம எப்படி அவுட்கம் பண்ணி புதுசா கொண்டு வருது அப்படிங்கிறது தான் சார் ரிசர்ச் அப்படின்னு நாம சொல்லலாம்.
Okay, fine, sir. He says some new thing has to be devised, and what are all the difficulties we may face in design. Thank you, Venkatesh. Nice answer, Mr. Vignesh.
Okay, thank you.
Why should we do research?
Sir, to contribute to the scientific community so that the humankind can grow and enrich in the future. That's
Okay.
sir.
Okay, Mr. Srimat, why should we do research?
So to share our innovative thoughts, what we have done in our research, in our projects, we can share with others so that anyone can get help from this.
Okay, excellent, sir. See, before moving into this, let me share one nice philosophy that I love. All may be knowing, our Tamil Nadu people may be knowing better. Arinyar Anna is a first chief minister of Dravidian party, that is DMK. And this is Anna Periyar, Kalaignar Karunanidhi, all are reformers to come out of this caste system, and they are instrumental in our reservation system across India, like Ambedkar, who is widely known. So let us not go into that part. See, in one of his speech, Arinyar Anna said, there is always two things. One is Swayanalam, one is Podunalam in Tamil. It means selfishness, common interest. So there is always a selfishness is one extreme, common interest is another aspect. There is no human being in the world is on these two extremes. Everybody is in between. So one is 100% selfishness, one is 100% for common good. So we always act in between. So if the swing is more towards selfishness, you will have money, but you will not have people to help you. You will not have people to appreciate you. If you more on the well-being side, the common good side, then you will have more people, but you will not have money. You analyze with very good standard politicians like Gandhi and so many other people, then you will understand this. So here, but we are all common people. We should have at least some component towards self, not only. So whenever you think any question, common mindset, what is it? What is there for me? So that is the first point you must think. I don't say it is a selfishness. We do something and I must get some credit for that first. I am giving you this talk. So what is the benefit I am going to get? Okay. So what I wanted to teach to my research scholar Gauri Shankar Instead of drilling to him separately, I am now talking to 300 people. So I'm extending the reach. That's all. Okay, let me look into the question. Why should we do research? These are all my perceptions. Ultimate degree one can obtain in life. It gives a professional satisfaction. I've studied up to the maximum. So why should we put Dr.PSS.Srinivasan PhD? Because it gives a recognition. And moreover, anything, you'll get a career advancement. So these are all again. Now, NIRF ranking has come the past 3-4 years. Every institution want to improve their ranking and want to be within top 200. And if it is within 100 to 200, they want to be within 100. If it is within 100, they want to be within top 50. There is a good, healthy competition. So it means every faculty minimum 2 publications per year. If you don't make, you cannot go into at least 200, top 200 list. So it means if you want our institution to be recognized as a quality institution, we want to get ranked. So this race has started, whether you like it or not. So now there is a NBA is going to be made mandatory 22, only 2 years. And like that, this tomorrow our management will include, if it is not as a part of a thing, if you don't publish 2 papers, you will not be given increment. If you continuously do that, you will be sent out. This scenario will come 3 years down the line. So let us equip now. So this is most important for survival under the NIRF, National Institution Ranking Framework regime. Okay, having understood, now anyway, if I go for interactive mode, more time is. So what are the requirements to get a PhD? Is it that difficult? Absolutely no. If you break up anything, if you think as a whole, it will always complicate it. Let us break into small things. What you have to do to get a PhD? Go to any university, they will give a guideline. 4 subjects as a coursework you have to do. Having studied 45 subjects in BE and 15 subjects in ME, this is not at all a big task. You can just like that, you can finish. 3 years of research, that you have to do, because if you want to get a BE, you have spent 4 years. If you want to get ME, you have spent 2 years. So the key lies in this 3 years, you have to plan for at least 2, publish at least 3. So if you have completed this, then you have to write one PhD thesis. So it is not merely compilation of what all these things. It's not at all a problem. Then 9 to 12 panel of experts, Indian and foreign, and that your guide will take care. That those experts has to recommend your thesis for award of PhD. If you have done a quality work here, absolutely one PhD, why it's a mere formality, one thesis is accepted. So what is important is 3 to 4 journal papers. So that is where the trump card lies. Now let me go into the next question. So let me take some answer from our most interested participant, Mr. Srimat. The question is, if you want to publish a research paper in a quality journal,
Yes, sir.
what are the things that journal will look for?
So first of all, they will look for like I have not copied from other journals like other. They'll check for
Okay. Plagiarism,
quality
okay.
of, yes, sir. And then
Okay.
what are the new things that I have mentioned, other have not mentioned. They will go for that.
Okay.
Then they will go for, sir, content of the paper, quality of the paper.
Okay. Very good. Very good. Super. Congratulations. Vignesh, what's your answer? Vignesh from PhD Tech, Sripathi is from Annamalai University.
Sir,
Vignesh?
yes, sir. Novel problem statement or novel solution to a problem is the key thing that a journal will look. That's my
Okay. Excellent. Excellent. Okay. Mr. Venkateshwaran?
No idea, sir.
Yeah.
PhD
From
now
he's
starting,
from.
sir.
Okay. Let us look into again. See, if you look very broad, that becomes a problem. I always say, look from very elementary dimension. See, research means already I said research for, you should go to the first slide. So research for something new or some new phenomena. So if that is there, that is what is required. Something new, what has to be new. It means you all said, I'm just putting it in order. And it must be original. It is done by you only, not by anyone else. And it should have a sufficient volume. Just only 2 graphs, if you explain, it may not have a sufficient volume. And it is not published so far. That is where the plagiarism check comes in. And every journal has say, I maintain this certain quality. To that level, it must be there. And preferably, if it is of current need, current thing, how to, I have given proposing a solution to solve COVID, immediately it will be published, even if it is of a little bit substandard. So that's a current need. So yeah, so if you new original sufficient volume not published so far, which journal you are putting, that journal quality, these are all essential. If it is of current need, then even if there is some compromise made here, it will get published. See, let me see how to satisfy this. So if you take any research paper, you read a research paper, you have to look from this lens. You have to look from this lens. Then only you will understand that research paper, and you can able to extract more out of any research paper that you see. See, the work is new, original, and not published so far. This is, you have to prove by literature survey. If you take any research paper, there is something called introduction. So introduction, one first paragraph is about your overall field of research. Then remaining 3 paragraphs, normally it will run through one page, 3/4 of a page. That is the maximum length allowed for literature survey. So what are the previous works people have done? So all these things you have to summarize. Then you have to, last paragraph you have to write, though many people have done so many things, but what I am going to, what I have done, what I am going to present here is important, but not done so far. That is why I have to done. So this is how you have to prove that by citing all other literature related to this, and you have to see that it is new, it is original, and nowhere it is being published. This is I am presenting it for. This is, if you, this introduction, if you don't justify, I will give an example later. Now understand what is the concept, then your paper will not be accepted. That's all. Then it must be of sufficient volume and journal quality. See, normally 6 figures to 10 graphs. I say we use graphs in engineering. You can use a pie chart, bar chart, or some tables, something like that. But normally the pictorial representation is more preferred. And if you have some 8 to 10 graphs, to that level, if you analyze a problem, that will be of sufficient volume. That's my experience. It is preferably of current need. This is where the the trick lies. This is possible only by choosing a research area, proper choice of research area. How to do this, sir? Okay. For this, you don't put a keyword and search. You take one journal content. Say if I am doing it in heat transfer, what are the top 3 journals or top 5 journals? ASME Journal of Heat Transfer, International Journal of Heat and Mass Transfer. Like that, identify 5 and see last 2 years, every issue content page. Then what kind of, which topic more of papers are being published. That is the current. Okay. Then that if it requires 1 crore level of sophisticated facility, we cannot do. So that is where we have to narrow down to our further level. Okay. Then, sir, last 3 years conference proceedings, again, it's very difficult to cut. My advice is, that's why
Hello. Hello.
Dear participants, am I audible now? Mr. Venkatesh, Vignesh, Srimat, you have
It
to
is
reply.
connected.
Yes, sir. Yes,
Connected.
sir.
Connected. Connected.
Is it audible now?
Audible, sir.
Sorry for the inconvenience. Some major disturbance in the internet for the entire campus. So we are all got locked. So I'm connecting through my mobile internet now. Sorry for the inconvenience. This is how technology sometimes makes. So now let me go into the presentation. Sir, I think all of you are there. And Okay. Sir, is it audible now? You are able to see my slides?
Yes, sir. Visible, sir.
Okay, thank you. So, dear participants, we have been discussing about how to satisfy an reputed international journal to publish our paper. So, new, original, and not published so far. So, that component we have discussed by doing a proper literature survey and writing the introduction and claiming that ours is something new, something original, and not published so far. And you see, when I wanted to attend my choose a problem for my PhD, it has come in a different way. But I personally feel ASME Journal of Heat, ASME in ISHMD International Joint and Heat and Mass Transfer Conference. Every once in 2 years, it is held in January across different places in India. So I go and register. Whether I have a paper or not, I used to register. Similarly, Fluid Mechanics Fluid Power Society of India conference every year. Solar Energy Society of India conference every year. So mostly if it is South India, I will definitely attend. Sometimes if it is very far north like Kashmir or from Assam, sometimes it may be difficult. Otherwise, I normally attend. So I will, whether I have paper or not, I will attend. Mostly I try to put a paper. So what will happen? You just don't do anything. Choose, if there are parallel sessions, choose a session of your interest. Go and sit in the middle of the audience and simply keep your ears open and one second, sir. Sir, am I visible now?
Yes, sir.
One second, sir. There is some complication. Well, speaker put dynamic mode. Well, are you there?
Yes, sir. I am online, sir.
Okay, speaker put dynamic mode so that the picture people can see. My face they can able to see. So you simply listen. You will find hundreds of ideas how different people are making different research. So that is how you will always learn. So every year, if you attend one such conference, reputed conference regularly, you will can update yourself. So I will make your mute. So how to identify one's research area? I told you got so many things. So first thing, it must attract you. While glancing through for last 5 years journal papers, I see content, not the particular domain. Or attending one reputed conference, something will see. Our heart will say, "Oh, this is what is something interesting to me." Because once you have interest, you can perceive. Then it must match your basic domain. If it doesn't match, it is very difficult. Some of them, when I was with Kungu, there were no recognized supervisors. Some of them with other domains, say engineering design. Oh, there is one PhD I have produced, and in the area of industrial engineering, one PhD I have produced. But that doesn't match with my domain. We struggle to complete, though we have some research, general research idea, but the guide expertise and your domain of interest must match. Then only if you have any difficulty, your guide will help you. Otherwise, you have to self-propel. It's very tough. We have faced certain difficulties. That also I will, if it comes to mind, we'll do. So this is how it must attract you. It must match your which subject domain you are more strong in the subject, and it must match with the guide. So now let me come into the key part. These are all the introductions. So these are the components of the research paper. Dr. Jayvel has covered very extensively. So I am not going into details of every part. So title, author, name, affiliation, abstract, keywords, And introduction, this is what I am always emphasizing. Review the past work. Say that you say that your work now, such a work is not done, but my work is important and present, which is being done and presented in this paper. So if my opinion, if you really choose some 25 research papers and understood 80% of the content of those past related paper, your 50% of research is over. But in my experience, people give very least importance to this. That is why the quality of research and the work is not progressing. So I have done condensation, heat transfer, enhancement on horizontal integral feed tubes. I registered in 1998. There is one research paper called 1988. It appeared, P.J. Marto, one review paper. So that research paper, I have taken 5-6 Xerox copies. I kept it everywhere, in my home, in my bag, everywhere. So that's a Bible. Whenever I get stuck, I used to read again. So I might have read in my 3-4 years, 200 to 300 times that particular paper. So we might have read, we know what is inside. But now the current issue in our mind, when you read the same research paper, then your mind connecting some lines. Oh, this is how it is being done. Okay, let me try this. So that is what. So this habit, this is a very essential habit you must definitely do. Then research and discussion. These two I will cover today. That's why I make it red. So introduction and research and discussion are most important. So dear friends, now let me go into a specific research problem. Because unless otherwise something is being told, you don't try to understand anything into it, but nuances of a particular problem, but parallels. If this is to this problem, it is like that. To my problem, it has to be like some parallels. You can, being engineers, we are good in making analogies. Okay, we solve a fluid mechanics problem using electrical network analogy. We solve a heat transfer problem using electrical network analogy, like that. So we are good in making analogies. So like that. So I have taken this as a major research area, performance enhancement of a solar still. Solar still means it produces distilled water, drinkable distilled water from a saline water using solar energy. Novelty suggested is use of an external condenser. It's already, concepts are there. We try to do something new there. The major subject area is solar energy, heat transfer, thermodynamics. As I said, it goes to applied research category, and it's a system level problem. And the nature of problem is a continuum problem. The research path we have chosen is experimental plus simulation, and not a computation fluid dynamic simulation. It's a system level simulation. No problem. So this is what is the paper. I'm taking it for example. Yes, I have taken a screenshot of the paper. So this is appeared in 2017. This is a specific problem. Let us not go into what is the topic and all. So these are the highlights, some graphs. Below that, there will be abstract that will be there. Let me not go into that. So this is a problem taken for research. This is a schematic diagram. This is an experimental facility they have made. So it is a solar still. It means this is a saline water, not drinking quality water. So sunlight is there. It goes into this glass cover. This is a insulated box. This is a glass cover. This is a tray and which carries water. So that is what is the setup. So it comes in. So because of this, water evaporates and the vapor goes there. Since it is linked here, it's only atmospheric temperature. There is a heat transfer from this vapor through glass. So vapor condenses. The condensate drains like this and getting collected here. It is taken here. You can see it is collected here in the bottom. Okay, they have put some thermocouples to measure certain temperatures for analysis. So anything in our engineering terminology or anything, what we want, something called performance. Performance means what? We give certain input and we want certain output. How to improve the output with the same input? Or for getting the same output, how to reduce the input. These are the two universal approaches done in everywhere. Okay. So input, but it must be there in the same units so that you can express it in performance. So what is the output here? The quantity of distilled water. So output here, efficiency, in performance here we use the name efficiency expressed in percentage. The quantity of distilled water produced, mass of distilled water produced, multiplied by, for this purpose, latent heat of vaporization, because it evaporates and condenses. Latent heat of vaporization divided by total solar energy that is being received across this surface. Okay, into 100 to make it percentage under specified duration. It may be 1 hour, it may be 10 hours. Or sometimes the residual heat may get condensed in time. So daily efficiency, accordingly, the word efficiency will become instantaneous efficiency that particular second, or daily efficiency either 24 hours duration or some daytime duration, say 9 a.m. to 5 p.m. This is what is the efficiency averaged over a day. So this is what is the thing we want. So our thing is we want to improve the performance. It means quantity of distilled water more for the given, because this you cannot control. Whatever you receive has to be there. So I think, so this again I have taken. See, why you should see is, so what are the parameters that affects this equation? That is what you have to see. So why I have chosen this paper is, this paper they are very beautifully listed. There are 100. See, dear friends, you try to understand 1950s to 2030, in this 80 years, there are about 20,000 research, 20,000 research papers are being published on only this solar still. Very widely researched. Even there, you have an opportunity to do research. That is what I want to emphasize. If it is of current need and nothing is being done, not much, you see the opportunity, enormous. So, why I have taken this problem? This is a very, because various branches of people are attending this. So, to make it light, so that people can grasp. That's why. So that paper, I said, that's why I said literature reading is more important. Several factors affect the performance of solar. Can be classified into three, anything like that. So external parameters, meteorological in general. In this case, it's a meteorological parameter: solar radiation, ambient temperature, wind velocity over the cover, atmospheric pressure and humidity, and the cloudiness or sky cleanliness. And design features. These are all needed to manufacture. So without some dimensions for every parameter, we cannot manufacture. That is what is the final outcome we have to give. And then again called operational parameters. By operating it under certain conditions, we will get maximum outcome. But during execution, this can be altered. That's why these are called operation parameters. This is there, it will affect, but you cannot do any control. So that is where these are called, in general, fixed parameters, or something that is very difficult to manipulate by ourselves. Whatever comes, we have to accept. Keeping this in mind, you have to design, fabricate it, and you have to operate it in such a way so that we'll get maximum yield or best performance. So observer dimensions. In the observer side, observer length, width, material thickness. And this is a glass cover is here, it is called as condenser here in this case. Inclination and thickness of the cover material, whether 1 glass or 2 glass or 3 glass. Again, you see, this is part that is observer is this part, this particular part. This is where the solar radiation born is being absorbed. This is a steel, it's a tray. Heat is being received. This heat goes into this water. Because of that, water evaporates. That's how the system operates. Then insulation. So this, whatever received by here, it must go only to water. It should not go here and get lost. That is why insulation. Then again, insulation, material, thickness of insulation. Then cavity aspect ratio. This is this mean height between. This is what is the parameter that is being analyzed here. Sorry. So my request is, every area you do locate, even it is some available here, otherwise you have to do this by reading so many papers. So once you identify what are the parameters that affects this value, this is what we want. This is right side, what are all the variables involved, that are the parameters that affects. That out of which there is something called, you cannot do anything, keep this as fixed parameters or noise parameters, and something called related with geometry, while without which we cannot manufacture this. These are called geometric parameters. These are all operational parameters. Now, do this table. Effect of various parameters on the performance of a simple solar still. So I have taken meteorological parameter, what is a symbol and what is the unit with which we are measured, what's the impact. Dash means no impact, 1 star means mild impact, 2 star means medium impact, 3 star means highest impact. Impact is on the positive, whether increases the performance or decreases the performance. I put a bracket because this dash should not be confused with this minus sign. This is no influence, this is a negative influence. So if you keep reference papers, I have not done this, my scholar will do for his work. And optimum value, is there any optimum value exists? Since these are all incoming parameter, it is beyond your control. That's why I put dash. If some research papers, in a particular research paper, some optimum value is being told, that you have to list here. See, next, design features. Again, symbol, unit, impact. How did you know this are? This I know the subject very well, that's why I have put it. Otherwise, if you read 100 research papers of the last 5 years, you collect all research papers, one might be analyzing on this. So that from that you will find this is the most influencing parameter. If you change this bit little, performance variation is much. So that is how it has to be taken note of it. Because of my experience, I have classified on my own experience. It sometimes there will be little deviation also. You see, I said something called optimum. This is where the optimum values are possible. And this particular study is only varying this parameter. See how many parameters there, how many manipulations are possible. That is where so many research combinations are there. Even if someone said optimum, you can do something and modify something, still you can do a research. That's possible. Then operational parameters. Again, the symbol, unit, impact. Either this is means up arrow I've said improving performance dimension. This feed water temperature plus means increasing the feed water temperature will increase the output or yield. And the saline water depth negative means if the saline water depth is more, then the performance will get reduced. Orientation of the still with respect to due south. So that is this is optimum. This is, we cannot have control. So that's why I said no control. So having done all, he said, after putting all his introduction part, he has put a title called Research Gap Identified. This is how, going through your 50 to 100 papers, you have to come to this is what this is exact words I have just copied from the paper and I pasted here. So this is how you must understand. You have to justify your works, that something is needed. That's a research gap. Evaluation of the basin type solar still for the influence of geometric design feature has seldom been performed in literature. This is not a very perfect claim because he has done only one parameter. There are other parameters people have done it, but still he claims. Even lesser experimental approaches have been found due to complexity in designing the variable feature of the solar still. This is again not, in my opinion, not a proper claim. Experimental investigation on the effect of specific height. This is not being done much, as he claimed. Thus need to be evaluated and established. That is why just such a justification is must. Okay, then this is again the exact words I have taken from the research paper I pasted here. Problem statement. You see, this is how. You see, for sufficient volume of clear problem statement, and you see that 8 to 12 pages, sufficient volume if you cover every topic. He says some novel experimental work on specific effect of specific height. And different specific heights have been investigated. That is what 4 type of specific heights are. In my opinion, whenever you want to plot any graph, minimum 5 data points are required, not less than that. So if he has done 5, then it would have been much better. But if he has done only 4, okay. And apart from this experimental, see, experimental is very costly, very tedious. So what normally people do is they develop some model. Using the experimental, they validate the model. Model is a computer program. So do lot of combinations in overnight and publish paper. That is why modeling is always taken. Then he is attempting specific height. So he has done some empirical correlation work. This is not a major work. And economic analysis, one small last paragraph he has added. Again, that adds some value to the paper. This is how the volume of material is sufficient for writing one full research paper. He justifies. Now let me go into what is the novelty he has claimed. See, this is the tray. Okay. So this mean height, this height, that is from here to here, this height has to be, if we vary, what will happen? So that is what is this claim. He has put 1 insulation, 2 insulation, 3 insulation, 4 insulation. And this is what is the thing. So he will remove this and make this means, and actually this height will, this is what the novelty he claims. You see, the word novelty means it should be something like what Newton has found out. So that is how you should not think. Even this is being claimed as novelty, and this novelty is accepted. It's being published. So that is why I said don't think something great. And yes, this I have just put a dot because I don't want to go through this. You take this paper and read it. He has done a very meticulously, he has written every minor aspect of it, so that in the review there will not be any fireback. Then it's experimental work, instrumentation, some table and other things that I have avoided. Again, just for an idea. Then how he has observed and how he has collected a data from 8 a.m. to 5 p.m., 9 hours over a day. Even step-by-step approach. So finally, this is for case 1. Case 1 means, say this setup, maybe case 2, case 3, case 4, something like that. See, this is the input, solar radiation. I said we cannot control ambient temperature. These two are the input data. This is the temperatures measured using so many, thermocouple. And this is what is the hourly yield. This is what is finally required. From this, you can calculate efficiency. Case 1 I have given here for want of time. Similarly, 4 more graph for case 2, 4 more graph for case 3, 4 more graph for case 4. And he has compared one in detail for one case. The next case again you should not repeat. Then how does the case 2 differs from case 1, case 3 differs from different cases, how does it compare? It has to be. That's a comparison. Then using this, specific height is a parameter he has measured. So something with respect to specific height, as on the right hand side, he's developed one correlation and some economic analysis. This is how a sufficient volume of research paper is being met. Okay, so now let me look into a simulation part. See, in the simulation part, again, this paper has done it. They have not presented that simulation part in a much interesting way. I have checked in another paper. So, effect of water and basin depth on a single basin solar steel. So, in this paper, just this part, they have also given a similar equation, but that's not being in a way that I expected. So here there are energy balance for the glass cover, energy balance for the water, energy balance for the basin liner. So 3 coupled equations, 3 unknowns. So by using simultaneous iterative approach we can able to solve, because one is linked to another. See, the point here is that this is one parameter. Anyway, let me come here. So what he has done is he has calculated the distillate yield, the current model, present experiment. This is how you have to validate your experiment simulation model. So 90% matches, 85% matches. So after that, this experimental part, whatever you like to do, it's very though physically doing, they will do on a simulation. That is what is advantages of this. Okay. So this is how I said how to identify a research problem. I have explained. Now let me move on to how to handle the, I think what's the time? One and a half hour already over. Okay. So how to handle the research and discussion part. Dear friends, this is where most of them will present only simply they present the results and they explain the trend of results. Why such trend has come? If you read 75% of the research papers, they have not at all touched. But if you, that is what is the essence of research. If you do that, then standard of paper is something great. So how to do that? So that is what is, this is what I feel heart of the research paper. One second. Okay. So let me go to slide share mode again. So dear friends, this one particular slide is the heart of the research. How to write research and discussion. See, any parameter you want, say efficiency here in the y-axis. X is a parameter that you wanted to vary. Anything that affects independent variable on the x-axis and dependent variable on the y-axis. Say for example here, distillate yield with respect to time. What is the parameter considered? This water depth of 2 centimeters, water depth of 4 centimeter, water depth of 8, 16. So if you put all these things in one graph, then it will be one graph, 2 line, 3 line, 4 line. This is how. So here the independent variables are 2. Water depth is a key independent variable, and that is being represented over time. That's why 3 it has come. But this is a calculated variable. This is what I want. So that is how it goes. So either the graph could be something like this: horizontal line, continuously increasing, slopes may be different, continuously decreasing, increasing and flat and then decreasing, decreasing, flat and then. So here the conclusion, y does not depend on x, horizontal. Y increases with x continuously. Y decreases with x. Y increases, then become flat and then decreases. So any graph, if you put maybe extend some combination of these 5 possibilities. In fact, these 2 are the possibility of this: increasing, flat, then decreasing. If you see increasing, flat, then decreasing this way instead of inward curve, outward curve. This is again, and so it may increase, decrease, something like that. It may go. Do research, plot your data, and find out what are they. This is your research is over. Here, no problem. Here, one or more mechanism. This is what it's your physics of the problem. Inside, this is what your subject comes in. One mechanism or more mechanism either support increase or oppose. When x increases from 0 to 10, say for example, then this particular force or this particular element, this particular say x, say friction force or this force or that force or some parameter, it increases, it supports. So that's why it increases, one or more. Okay. So depending on how much it supports, the curve, slope of the curve varies. Here it opposes. That's all. Here, when you want to get this kind of thing, minimum 2 parameters must exist. One person must, one component or one fellow must support, another fellow must oppose. So depending on whose influence, net force, this will increase. So here, the let's say A phenomena component mechanism A is supporting, mechanism B is opposing. Here, if you take this point, this magnitude will be this much, this magnitude will be this much. So this is the net. So this cause of this point moves from here to here. When you come to this flat region, both opposing supporting, this is a length and this is a length equal. That's why it becomes flat. When you move from this to here, some influence is being reduced. So this fellow, downward fellow dominates full length and this upward fellow is only small. So this is a net. That is how it increases. So this is how, when only for these cases, something called optimum exists. Now, go into this equation, because this is a basic equation. Again, I am not going to the subject. See, this is here. See, solar radiation. Okay, solar radiation, IT, that comes here. Okay, so when I increases, then the efficiency will increase. This Tg minus Ta reduces ambient temperature. Ambient temperature you cannot have any control, but increase in ambient temperature will reduce this temperature difference. So it reduces the heat loss. So this is how you have to establish. So like that, for every parameter on the right hand side, I have given the things. Okay, so let me take this glass cover inclination. Say one example. So sun is here. Maybe this is in the forenoon, this is in the afternoon, let's say. This is the east, this is the west, say for example. So if the slope of the glass cover is here pi 1, you see the shadow is, so this much portion is lost. This much portion receives the solar energy. So the area received is more, the heat transfer quantity absorbed will be more. On the contrary, if you increase the slope here, morning side, this height, this is fixed because this height is already fixed. Only if we increase the thing, only this side it is varying. So like that, you can see here more shadow. So this much. So naturally, if you increase this mean height, this is a problem studied here. That's why I put mean cover distance. But you see, this is a mean cover distance here. This is a mean cover distance here. Okay, that increases because of slope also. So that is why there exists an optimum for a particular location. This may not be the same. So about some 10-12 research papers they have done, when optimum pi is equal to the latitude of the location for year-round performance. If you want better performance in summer, it must be -10. For better performance in winter, it must be +10. So that is how, this is a conclusion people have come. So each parameter objective is performance enhancement or getting more yield. So continuously increasing or decreasing, continuously increasing or decreasing. So use the cost benefit, and we have to decide on one value. So here it is continuously, if you increase the insulation thickness, heat loss decreases. But for insulation, you are investing money, because to buy an insulating material, the 1 inch thickness cost is X, 2 inch thickness cost is 2X. So you have to use the cost benefit analysis. Or if it is an operating parameter, you have to apply fixed cost versus operating parameter to decide what values should I use in finally operating. If it is an optimum, increasing, flat decreasing, or decreasing, flat increasing, then minimum 2 mechanism, this itself gives you an optimum. Absolutely no need. Dear friends, kindly understand, this is a great learning for me after going through some 2000 research papers. This is called order of magnitude analysis. Okay, this is called order of magnitude analysis. I think something goes wrong. Okay, sir, are you able to understand, Mr. Venkateswaran? Mr. Venkateswaran, Mr. Vignesh, Mr. Srimad?
Yes, sir.
Sir, are you there?
Yes, sir. I'm there, sir. Vignesh.
Whatever gone so far, can you able to understand, sir?
Absolutely, sir. Yes, sir.
Thank you, thank you. It may not be absolutely, but to certain extent at least. Thank you. Dear friends, keep this in mind. This I have given some. See, there is something called order of magnitude analysis. Say, for example, I've taken one random. You want this is a term in your equation. So that equation could be something like this. So this equation, this is one term, this is another term, this is another term. This is how normally A equal to B plus C plus D. This is how we write. But in reality, sometimes the equation could be something like this also. Both the sides may be there. Okay. So you see, this is term 1, term A, B, C, D, E. Say for example, equal to F, G, H. These are the value of each term. So 5,000, 5,000, 550. This is order of magnitude 10 power 0. 10 power 0 means 1 to 9, 0 to 9. This is order of magnitude 10 power 2. This is 10 power 1, sorry. 10 power 2. 10 power 2 means 11 to 999, 10, something like that. So if you see, you have an equation like this. On the right hand side, you have an equation like this. This is perfectly okay, 100%. Now, this equation becomes unsolvable because of too many terms. So what I do, I drop this term here. I drop this term here. In the equation, don't think here, this number I have given only for analysis purpose, understanding purpose. So now the answer becomes 10,400 instead of 10,555. So now let me drop these three terms, 1, 2, 3. So this side becomes 10,000. So 10,000 equal to 10,400. Okay. But 10,000 is the value. One side you are justifying. This is not equal. This equation, this side minus this side equal to some error. You have to reduce that error. That is how this analysis has to be done in an iterative manner. You see, 5.5% error. By you have dropped here 2 terms, here 3 terms. So 5 terms you have dropped. Still you get 95% accuracy by solving this. So instead of keeping this equation unsolvable and struggling, let me do some sacrifice here and compromise on some 5 to 10% accuracy and make this problem solvable. This is a beautiful approach we follow in fluid mechanics while solving the Navier-Stokes equation. Dear friends, those who are in mechanical know, other branches may not know. Today, the world's most complicated partial differential equation the world ever has found out is the fluid mechanics. It comes in fluid mechanics, especially in turbulent flow. Okay, so that's very difficult to solve. Some 20 years back, when supercomputer America has invented supercomputer of then supercomputer, they put this Navier-Stokes equation in full form. It took somewhere around some 10 or 12 days to solve. Imagine all this weather prediction, this tornado predictions, all these things require this kind of super flight simulation, ISRO satellite simulation. All they need this kind of solving Navier-Stokes equation. That is where. So there is one term called phi that to tell that if you write on hand, this Navier-Stokes equation will run for 3 pages. One equation will run for 3 pages. To make the thing understand, we'll put one term viscous dissipation as phi. That phi itself will contain 1.5 page length of characters, terms. But that phi normally 2% influence it has got in most of the cases. Okay, only in friction dominated flows like flow of say, castor oil or a coconut oil, some thick oil over this. Only in the lubrication space, that is a predominant term we cannot neglect. But all our cases we can neglect. So that is why I said this is where you can put 3 star, 2 star. What is this or how? This is how it comes. So whether in this is a correct answer. Contribution to this correct answer, whether this is value 5 or value 50, value 500 or 5,000. So if it is something value is 5, if you focus in doing research on this particular, let me say, effect of basin thermal conductivity, this is only a 5% impact on performance of solar steel. You cannot claim something big. So having done all, you might have seen why many people might not have touched this. Oh, no one has done, let me do it. If you start doing, you will finally get only 5%, 3%. So no journal will be interested to publish some 2% improvement I have done, something great. If you claim, they will not do. So that is why, again, this particular order of magnitude analysis you can use for your personal life. Any problem solving. Okay, suppose your wife says something. Okay, so you have to put that particular thing, whether it's a matter of 5 or matter of 5,000. That's 10 power 4. This is 10 power 0. So this, if you don't do it, then today dinner you will definitely have. This you don't do it, 1 week dinner you may not have. So Corona period, even hotels are not there. Imagine our situation. So that is where. So two students fighting disciplinary problem. Whether it is a problem of this magnitude, this is a problem of this magnitude. If this is of this magnitude, let us, the class teacher levels, solve and do something. Let us not waste principal's time. If it is of this much problem, then if you allow a class teacher level, that will magnify and your job will go away. So that is how. Okay, so this order of magnitude. Suppose if a person, faculty is coming, sir, I need to do something. Kindly approve. Then I will ask, what is the expenditure involved? 500 rupees, sir. No problem. Proceed. Follow the formal procedure to get the money get, but you proceed. Even if the top management doesn't want to approve, 500 rupees I can put for the signature that I have put. I can do my, from my packet, I can satisfy the faculty. If it is a 5 lakh rupee, imagine. So this order of magnitude analysis not only applicable in research, it is applicable in every day-to-day life. So kindly use it. So now I'm coming to the almost end of it. This is how the solar radiation comes, evaporation takes place, and this water vapor mixture is there. Here it gets condensed, it's getting collected. That's how it is. This is a different from subject point of view. This is incoming, and this is being heated, and this heat is being moved here. These are all different mechanisms, and you see, because of sun's rays, the basin temperature is the highest. Heat transfer will flow, heat will flow from higher temperature to lower temperature. So it will go to water. From water, this is water. It will go to glass cover. From there, it has to sky. In this process, the condensation takes place, and this is what we are interested. This is what. So, what are all the different mechanisms? In every path, you can write one equation. See, that is what these equations are. Here, I said, if you want MB, you take this. Whether if you reduce, your performance will increase. How? I have written here. If you put CB, this is a specific heat of the bottom plate. Instead of copper, if you choose plate with more specific heat, then it will, this itself will store more heat and it will not give to water. So this, and what kind of surface coating you have to do on the plate, alpha B. This you cannot do in a normal still, but still there are about hundreds of research on how to bring in more solar rays into the same area. So that is on reflecting and focusing techniques. This is again, there's another area of research. Everywhere I am telling we can do something, but this is a minor parameter. This is a minor parameter, order of magnitude wise. If you attempt, then you won't get much. But this is a major parameter. And that to maintaining this observativity over a period of 2 years, 3 years itself is a very complicated one. So, but that no one will do. No one has done so far also, to my knowledge. And again, this is where you have to play so many things. And this is fixed. Like that, every equation you can able to do. What will happen? Again, use order of magnitude analysis. Whether it's being done or not, if it is not done, you can choose this for a problem. Okay, this is how it goes. So here, as I said, this is one equation. This is one parameter. This is a function of 3 heat transfer coefficients, wherein we are trying one now external condenser we are introducing by which By removing vapor, it will improve definitely. But again, there are some 20, 30 types of condensers are being attempted and results are being reported. But none of them are very easy to implement in real life practice. But we are going to introduce one novel. You see, this is what is called external condenser. Take some vapor from here and condense it so that more and more evaporation will take place. That's why you will more. Here also you will get one yield, and here also you will get one yield. So instead of something like this, we are trying. This is what I said, different places you can manipulate. Because of want of time, I'm cutting down. Now, let me give introduction to what I am going to talk now tomorrow. My experience, but that will be focusing on this. See, this is my entire subject, heat transfer. There is 3 mechanisms: conduction, convection, radiation, condensation, boiling. This is a part of convection. And applying this, some heat exchangers. So this solar steel is a heat exchanger. And this is what is conduction, convection. That's why I put this. C is a function of KAL. So everywhere you can play, wherever conduction is involved. Similarly, this is convection. It is a function of 6 parameters. These 3 are the fluid properties. This is a flow field and this is a geometry. Everywhere you can play, but once you choose a fluid, you cannot play here. Okay. That is where the hinge lies. But this is where if you the lines. So V, velocity of flow. So you can see it velocity of flow. If you increase by, it increases to the order of velocity to the power 0.8. But the friction goes velocity square. So it means you cannot indefinitely increase. So we are. I said cost, operating cost versus fixed cost. This is what is the trade-off here. Of course, radiation. So numerous possibilities exist. That's what I said. You see, combining each parameter like here, like this, each parameter in this, and what mechanism is there, and combining this equations. This that's all I said. Numerous possibilities exist. Okay, this is what you don't think, sir. How to choose a problem? You give me one research paper and they make 10 minutes presentation. I will write down 50 research possibilities. It is there that you yourself can identify. That's not a big deal. How to do that, and which one will give a definite outcome, which one will give a least impact, that you can also understand by reading the literature. So next talk I will take my experience and few case studies. And dear friends, in the Bloom's taxonomy, in the outcome-based education, we say all problems are complex and complex problems require. Our PhD fits in this kind of research. If you try to do something here, it won't work out. Let me move on to the closing remarks. So my remarks are, today's lecture, anything in the world can be analyzed. That anything in the world. Okay. Say for example, take this initial I told about drinking tea in the tea shop. Okay, then 5 tea shops you choose. How the taste varies. How it tastes varies over a day of 365 days. Okay, why this particular fellow's tea is good? Why this particular tea is less tastier? This is least tastier. Everyone puts the same thing: sugar, water, and milk, and the coffee powder or a tea. So what brand use? How many combinations? You look into any research paper, no research paper is published on. This comes in empirical research part, that statistical research part. So far, no paper is being published. You have a potential to publish a paper. One tea shop, bakery, that puffs heating oven. One of my students wanted a very interesting practical problem. I have given to Dr. Navneet Krishnan. How he has put 7 international journal publications. In the next talk, I will tell you. Even that is how you can find out a research problem. So anything is not in the world, but in your imagination is also a better research. Anything beyond your imagination is also a scope for further research. So what is important is some outcome of the research. So essential increments of better research are, again I said, I believe in literature survey. and consistent perseverance work for 2 to 3 years, and attending repeated conference in the related field, at least 2 per year till you complete your research or guide your research. This is where many of our scholars lack time management. I will tell you how to do time management in my next talk. So to conclude, I am coming to the last slide. Intense research habit, planned, systematic, and hard work, little bit of lateral training, little bit of luck. So the world is waiting for your contributions. So this is one of the famous quote. A researcher uncovers the unknown. A diplomat, maybe a politician, covers the known. A professor covers the known to all and covers the unknown to himself. This is a difference between a professor. Most of the time we do here. We are not diplomats. You want to move to this domain, you have to do a little bit mindset change. So 50 years back, these were there, but now it doesn't exist. Means how much research would have gone there. Okay. So we have come to the final part. All the best. Thank you. Now it's a time for questions. Sorry, because of the delay, some little bit, I thought of completing it 1 hour. It has become 1.5 hours. So now it's a time for questions. Any question you can type in the chat box, or otherwise you can raise your hand. We will take it up. So I think probably another 10 to 12, 15 minutes we can take up the stop here. Okay. So Siva Naga Raju, sir, you have been unmuted. You can ask your question. Siva Naga Raju. Next is Sendil Sivanathan. Sir, you can talk. So Sendil Sivanathan. Sir, I have unmuted you. You can ask your question.
Yes, sir. I just wanted to get some more insight on interdisciplinary approach in any research, sir.
Excellent, sir. This is what is the need of the hour. Everywhere the core fields are being researched. Only in the interdisciplinary field, there is a lot of scope to publish. One example I tell you, as I said, one of my research scholars did research in the operations research area. That's industrial engineering area. I'm not an expert. But since there is no guide available at the time in our department, I accepted. He took some help from NIT Trichy and he has completed it, and he's a joint supervisor. But what I found is that there are some optimization techniques. One such simplest optimization techniques is design of experiments. So if I have none of my heat transfer conferences, so to the point that I introduced, no one has even know about what is this. But I found while doing our research, if you do in a little bit different fashion, we can add one paper as optimization using design of experiments. Even this is also a part of mechanical engineering thing, but that approach, heat transfer community doesn't aware of it. Then most of my researchers who has come, 3 or 4 of them has used, that has given one research paper that is being published and accepted very well, because as I said, there is a novelty in solving the problem. We claim that as a novelty in solving the problem, not novelty in the product or something. So this is how it is possible. So that design of experiment part, I think Dr. Parthiban will cover.
Okay.
I told him, if not, I will give one more talk, my third talk, I will do that. It's a wonderful idea. You can say now biology plus, because a lot of things, sorry, anything is finally is an optimization. Okay. So there is a, see, I left focus on research about 10 years back. I'm not a full-time researcher, so I'm a full-time edupreneur. Now I have to see finance part of my institution also. So that is where my time I have focused shifted. I attend only HR conferences, not heat transfer conferences anymore. The past 10 years. But one Mr. Thomas Bivan, He has written a book called Statistical Thermodynamics. To date, only there are 2 books available, and one is very old, and this is latest.
Okay.
Statistical thermodynamics is very complicated. He is very renowned person, and Thomas Bivon was something like Abdul Kalam. You like to see talk in the heat thermodynamics area. So he was the plenary speaker in one of the heat transfer conferences held at Calcutta. But that time there was a Kargil war, and he did not come. So I missed this opportunity. That's he has got geometrical optimization. He introduced one optimization called geometrical optimization. The problem he took is how the Africa's Amazon River, how our Kaveri River, how our Ganga River was there 100 years back, and over 100 years how it changed its track. Of course, little variation, not much. So it's a natural optimization. So can we use this for solving a heat transfer problem, especially the heat sink problem? The electronic chip cooling, electronic chips produce a lot of heat. Most of the electronic fail because of the overheating. So the chip will be of 1 centimeter by this much thick, this much length, but the heat sink attached to this this chip is actually make a still very small. So
Some technique. Are you able to hear me, sir?
Things are because of.
Okay.
Is it audible now?
Now audible, sir. Some problem is there, I think. Okay. We will discuss later, sir. No problem, sir.
Sir, unmute plug, sir. Sir, mic unmute plug.
Yeah, are you able to listen now?
Yes, sir.
Yes, sir.
Okay. So this so many such possibilities exist. So today the hot topic is biology plus anything. Biology plus fluid mechanics, biology plus heat transfer, biology plus electronics, biology plus something. See, the 10 years back, the one last conference I attended, there was one paper. You see, this is how fish. Okay, there are two. This I don't know in English. Okay. Now, for a ship model, or ship like this, he introduced one rod here. By moving this rod here like this is a ship. By moving the rod on the both the sides, something like this. Okay, we are able to reduce the force by 40%. The ship has to sail. Imagine 40%. So that is possible. That he says by how this wings of fish performs. By studying this, I have done that. There is a lot of such things are possible, sir. It's a wonderful idea. You can seriously try. It's a very easy. Some novelty you will get published faster. So next participant, many have raised, and I think lower the hand you can raise. If there are chat boxes, you can.
Sir?
Yes, madam.
Sir, I will gather certain questions in chat box, sir.
Okay.
I'll raise the question now. Person Dr. Bhupesh Kumar, he has raised how to improve the English language for writing papers.
It's not only required for necessary for our day-to-day teaching also. You take any external coaching agency, systematically do. We have engaged one agency at Coimbatore called Carl's Caliber. Whether he is doing now, he is very aged. He is a retired colonel. Carl's Caliber. He has got one particular writing methodology, and that improves very well. And this is a very essential part, sir. By doing some you have to parallelly join in some English coaching center and improve your written English. That's must. Next.
Next question is Ganesh from Viltech. Is there any limitation minimum for preparing a literature review?
No, literature review normally last 10 to 15 years we have to collect. First you collect last 5 years, then you extend it for previously 10 years. The last why? Because certain equations they will take from 15 years back, 20 years back research paper. Without such equation, it is not possible to solve now. And you see, early days paper will talk more on mechanisms and fundamentals, and the recent papers will talk on assuming that these things are known. They will talk. So that's why for a beginning researcher, we need fundamental mechanism. As I said, the key in research is identifying the research problem and sharing this particular this is the most important slide in your life. This I read some 2000 papers, and this slide comes out of this experience. What is that? In my case, this is a most important graph in your life. If you understood this particular graph, whatever said in this page, I feel your literature survey, identifying a problem, using order of magnitude analysis, whether some benefit, beautiful outcome will come or not, plus this particular page. If you have understood this, then 90% research is over. Mere 10% is to find some data for this. Oh, next question, madam.
Sir, Vignesh Karthik from PSG. What if no equation is available? How can an order of magnitude analysis can be performed?
Yeah. You see, that is what is the beauty of this equation. You are once you develop an equation and try to solve. If you don't able to solve, drop some terms based on your intuition and find out. You have done experimental research. You have calculated using simulation approach using equations. Some deviations will be there. If the deviations is 30%, 40%, then you have to check whether you have modeled correctly. If your model is correct, still the deviations are more, you have to check whether you have used proper accuracy of instruments for, you have to do error analysis, experimental uncertainty analysis. If that is also correct, then the term dropped is of significant magnitude that you should not drop. That is how we can. So this normally, if your guide has guided some 5 PhDs in a particular area, he can, out of his own intelligence, he can able to say this will work out, this will not work out. See, if you come to me now, you suggest any topic in heat transfer, first I will do whether you need a sophisticated experimental facility or with the least experimental cost experimentation, it is possible. Because if you have no problem, otherwise it is very tough. So that if that fits in, then I will ask him to go through last 3 years paper and come out with top 5 paper that you feel more important. Then present whatever comes to your mind, just project that paper and explain for 10 minutes on each paper. Then I will take a 2-3 A4 sheets. This is a problem for you. This is, if you do this, you will get paper 1. If you do this, paper 2, 5 papers. And for this will be the final thesis chapters. In 5 minutes, we can do this. And you have to read these things before starting. So that is possible. If you follow whatever procedure I said, it is very, very easy. But for a beginner, you may have some confusions, but it is always possible. Research is an experience. So only by doing, failing more, what like Thomas Alva Edison said, 1999 times, I have not failed. I have found out how to do better. So that is the way we have to. That's why I said the word perseverance. Next question, madam.
Sir, Ganesan is a research scholar. To prepare a review journal, is minimum number of journalists depend on the field oriented?
Sir, in my opinion, research review papers in publishing is not possible in journal for a beginner researcher. It is possible only in conference level. Normally, there will be an editorial board, and in this editorial board, for every field, say if it is a heat transfer enhancement in area, there will be 2-3 people. On the ASME journal of heat transfer, they are almost there for 20 years. Only those people read a lot of research papers of all people and do preliminary screening. Then it will go to experts. So they know the trend. They are the people. You see, only those 2-3 names will be repeatedly there in all review papers. Only that kind, those quality journals will publish. If you and me attempt, then they may not publish. So review of literature is for our research paper introduction and similarly for our thesis. So that is what I mentioned. If you want to write a review paper as a research paper, then in my opinion, it is very tough in a reasonably reputed journal. Next, madam.
Sir, next question from Vimala. She asked how we will find out free quality journals.
Quality journal, that is not at all a problem, because if you put journals in heat transfer, only most referred journal in Google search will come first. So whatever top 5 comes in the list, then that is a quality journal, because more and more people refer that search engine will give it at the beginning. Or otherwise, take any 2-3 papers and you see the references. Which journal is cited frequently? They are the most reputed journals. Go to madam.
Yes, sir. The next question they are asked is how to prepare review papers. Just now you are given guidelines for them. The next is Mekala Ramasamy. He asked, sir, what is the range or number of papers need to be referred while writing a review paper?
Yeah, review paper minimum. Yeah, I have seen the question, madam. Minimum 50 papers, somewhere some 120 up to 120 I have seen in the review papers people are reviewed. But for writing a normal research paper, 10 to 15 or 16, if you refer, that is more than enough. Okay, next question.
Which papers need to be given preference? Either latest papers or all the relevant papers related to our problem which we have chosen.
Yeah, normally if you refer one last 5 years, if 2-3 review papers are there, if you cite that paper, that itself is enough, because that have taken all previous papers into their fold. Okay, then see, in your case, you are justifying a problem. Okay, then say for example, you are analyzing the particular height, that is a height, mean height between the water surface and the glass cover effect. Then what are all the other parameters you have to mention? And these paper works are being put in these review papers or discussed. And the outcome is this. You can do, this is most important, this is least important. This has got high impact, this has got low impact. But when it comes to height, whatever paper that is already some 10 papers are there, each paper you have to mention and what is being attempted and what is missing and what you are attempting. That is how you have to finish your introduction part. Go to madam.
The next question is Basavaraj. He asked us, how do we track current parallel work carried out on the same problem across globe?
Yeah, that is a very, very interesting question. That's what I suffered in my case. I did something, and before I published, the same thing has been published. So I have to take a deviation. So that problem exists, but we can't help much. So, but if you attend because journal takes 1.5 years to 2 years to publish. If you attend a conference papers now it is easy to get because they're not like my days. If you take the conferences, naturally you will find out, oh, this group is also doing something similar to me. So that is always possible. Visagwel, are you there?
Sir, that's all, sir. Questions in the chat.
சார் வந்துட்டு ஒரு மீட்டிங் போயிருக்காரு சார். சார் வந்து டேக் ஓவர் பண்ணுங்க.
Okay. சொல்லுங்க மேடம்.
Sir,
Yes, madam.
Dr. Jayalakshmi, sir, without having any experimental work, is there any possibility of writing research paper?
Yes, madam, you can write a research paper for your analytical work or for your simulation work, what you have developed. You can use, anyway, tomorrow my research path, I will tell you how to validate your experimental model, how to validate your experimental facility also. You have created one facility. What is the guarantee that it will give a good results? It will, what results it has given are correct. So you need to validate. How to validate? I will explain in my next talk. It is possible, but if you want to do a PhD, if you see, PhD is not publishing papers. PhD is a degree. You learn how to do research, how not to do research, how to do time management for research. So that this is only a learning, your PhD. Thereafter, you will be guiding minimum 10, maximum some 25 PhDs in the another 10, 15, 20 years. For that, you need an experience. So that is what is our PhD. That's why I say, you want to do PhD, take a simple problem and comfortably complete and get your PhD first. Be selfish. Then take a complicated problem that you are capable of solving, give it to your research scholar and solve it. For that, you also has to help because you are punishing him by giving a tough problem. Have you got? So that is how you have to be a little selfish in your case. Now your student must be, if you think that way, then some matching has to be done. Next, madam.
Sir, Jiva from MAMCET, how to handle the failures during project?
How to handle?
Failures during project.
That is an excellent question. That is what is my next talk. What are all the difficulties I have faced? How I have overcome? Because that experience is most needed for many researchers. That will have definitely, you listen to my next talk, madam, and if you have still doubts, because that will be another half an hour talk. Over to next question.
Sir, Dr. Babu, Department of Mechanical Engineering from Narasimha Reddy Engineering College, Hyderabad. His question is, he wants to keep in touch with you to write about the research article writing.
Yeah, that's my mail ID is there. You can mail to me, but the only problem is that I may not reply instantaneously. It may take sometimes 1 week to reply. That's a problem because my priorities are something different. Definitely, you can take a help. See, anyway, I thought of sharing it in the next meeting. One Mr. My friend N.K. Karthikeyan, he is working in Coimbatore now. He is an EC person. One day he came to me and said, PSS, somewhere my research is not moving. Then I told, give me 5 papers that you feel most important. I have not understood anything. I have just glanced through to have a feel of it. Ask him to talk about your research for 1 hour. He has presented something. Again, 10% only I understood, 90% I have not understood. Then I have taken a paper. You can try this. Common sense. Some 10, 15 points. Then he came and said, after 6 months, I have completed my work. What he did, again, his part. So this is what is required. Some kind of external intervention to trigger you to think you in a different way. Okay.
So next question is Rajesh. Sir, if I'm doing a research on composite material, if the same topic is published on current year, how to?
Yeah, I said, I understood, madam. Sir, I said, n number of possibilities you can vary. Okay. So you must choose such a topic. You must choose this in such a way that not too narrow. If something is done, I cannot do anything. So vary some combination. Say, for example, heat transfer, this particular problem. I said, if it is a fluid, then the fluid thermal conductivity of the fluid is more, there will be more heat transfer in convective heat transfer. That's a very basic thing everyone knows. So if it's water, it has got some value fixed given in the data book, and if you measure, you will get that value. I cannot do anything. Okay, this was the case for so many years. Now this nano, one word nano has come. Okay, nanoparticle. So if you mix copper nanoparticle with water, you can increase the effective thermal conductivity significantly. So this alters so many research. Imagine, so many research. Similarly, insulation, we want to reduce heat transfer in conduction. So this is a slab, T1, T2, I want to reduce. So in this material, thermal conductivity plays a very vital role. Okay. So if you look into heat transfer data book, all gases will have a thermal conductivity of 0.0 something. So 10 power minus 2 is the order, again order of magnitude. All insulation material you take point something. So 10 power 0 or 10 power minus 1. Not even point something is very less, rare. 1 point something, like that. If you take copper, it is 330 watt per meter Kelvin. So it's imagine this is a spectrum with which we need to operate. So instead of making this as a polyurethane foam, it is nothing but in between there are air packets wherein you are having air. So if it is a solid, its thermal conductivity will be 2 watt per Kelvin. In between, you make as much air packets as possible, so that there should not be internal natural convection. That's that much smaller, and incorporate more and more air and make this form. So what happens? This is 0.026. This is 2, and the effective thermal conductivity you can bring it somewhere between 0.036 and 2, close to air. If you air volume fraction is more. Imagine how much combination exists. Can we use this on a roof? Thermocol you cannot use. That's one research. He has guided 2 researchers in the same area, my scholar. That I will share tomorrow. So there is n number of possibilities exist. That's why I said you subject mechanisms. Problem, you have equations. Where you want to manipulate, which magnitude. Okay. So that is what makes infinite possibilities for any topic to research. Okay. Sir, everyone smokes cigarette. Go and search heat transfer in cigarette smoking. You will find 126 papers. Okay. There are beautiful things. Don't think problem is a problem. You can vary the problem in n number of combinations. Yes, it is parallel, something might have published. Okay, no problem. You take that as a small 1/3, add 2/3 more by twisting something, and do this. Yes, so the very first question came, take some parallel field. Go and sit with electronic wavelet design, electronic transmission design. Some listen something that can I do some combination of this. It will it will a new field of research. See how this Thomas Bevan used natural variation in the sea flow to develop an optimization technique, geometrical optimization. He named so. I was really if I would have pursued my research, I would have taken that as the topic to redo all my problems that I have done already using this geometric optimization method, because that's a newly introduced method. There is a good possibility to get published faster. So one Ms. Padmatriya, last question. Madam, you have raised your hand. Yours is the last question. If at all any questions are there, we'll have in the next talk. If you need one more to answer only QA, I will do that. Padmapriya, madam, you can ask your question.
Sir, good afternoon.
Yes, madam.
My question is regarding those exploratory areas which are very new. Nothing, no material is available in that. Say, for example, if I am talking about some biotechnological area, like studying the depression elements of students and accordingly preparing the models for understanding their depression status before they actually go. This is regarding, say, for example, if I want to prepare some model for students who are probably or for the candidates who patients which may go into the depression, and I want to know about the symptoms of depression before they actually face them. Okay, if I want to prepare the model for that, so in that case, this is something which is very new. Nobody knows about this. Nobody has even done any research on this.
So
in that case, how to go about sampling?
You are
go about sampling?
Let me come to understand your problem first. Let me paraphrase what you said. Depression of people is a major area, and some biological parameters using as an indicator can identify depression. Am I right, madam?
Correct, right, sir.
Okay. See, major area is depression. Minor area is how to identify depression. The specific topic you choose is a thing. It comes under statistical research, hypothesis testing. Okay. So you need to take a sample, and how sampling has to be done. Again, this one talk we have arranged, Dr. Murugesan will talk. I am aware of little bit, but I'm not an expert. So when it comes to an expert talk like research, without so at least some 60-70% authoritative level, it is not good to answer. But anyway, I'm giving an outline, because in mechanical engineering, in the statistical quality control is one subject we teach, in fact. So how to identify a sample out of the mass? That's number one. So again, how to collect data, and whether you are using some survey technique, using some kind of Google Forms or an interview technique, and what kind of questions has to be framed, so that it becomes an inference for a statistical analysis. Okay, normally Likert scale. If you want to do any statistical analysis, you need some number. Even perception has to be put as number. Observation has to be put in a number. Excellent, very good, good. This is again some segment like that. Then based on that, you have a very standard statistical way of testing using softwares like SPSS, and whether hypothesis is true or false. To 95% accuracy, 90% accuracy, confidence level. They don't use accuracy like in engineering. Confidence level. So that is how these researches are being done. It is possible, madam. I think probably you have to listen to his talk. Okay. That is why for covering entire spectrum, we have arranged various resource persons. Over to Padmapriya, madam.
But, sir, can we do the modeling in this connection?
Yes, anything is possible, madam. Now, in my first slide,
these are the symptoms 1, 2, 3, 4. This is what is the level 3, 4, 5, 6. This is like, can we do the cluster analysis for this?
Yeah, I tell you, what is the parallel field like your field? You take any marketing of a product. Okay, a similar approach is being used. Are you getting my point? So, what are the techniques people use? Suppose you are bringing a particular new brand of instant coffee. Before introducing, people will do some market survey. So, what are all the techniques that are being used? Similar parallel can I use with some modification? That is how we have to start.
That's true. Right, sir.
That is how we have to approach.
Yes.
If you specifically share what is the thing that I can able to throw some light on it. Because without understanding a
Yeah, okay,
specific,
sir. I will separately write you in case if I face any difficulty in this case.
yeah, most welcome. If I know, I will answer. Otherwise, I will link to someone. That is what is my because I have good connections. So this person may know this, so I can link to someone so that you will get some guidance. Thank you, madam.
Definitely.
Thanks for joining.
Yeah, thank you.
So I think there is a limit for everything. So we have exceeded too much. So over to Sandhya madam to formal closure. So next Thursday will be a story for some period, how I travel. Then more time will be there for question answer, so that you can raise many questions. So come with a lot of your questions in mind. We'll meet next Thursday. Till then, have a great day. But think about doing research. Think about doing research. 1 hour per day, 5 days a week. Keep it in mind. So with this short note, over to Sandhya madam for further proceedings.
Okay, sir. Thank you very much for your presentation. Still, final one more question is in chat. We will take in that forthcoming weeks to come. And now it's over to Krishnan for formal vote of thanks.
Yes, thank you, madam. Am I audible, madam?
Yeah, you can proceed.
Yes, thank you, madam. A warm good afternoon to all. I am Krishnan, working as Assistant Professor in the Department of Civil Engineering at Knowledge Institute of Technology, Salem. It gives me an immense pleasure and profound gratitude to propose the vote of thanks for a thought-provoking, high-end research webinar talk on everyone can do a quality research. The session is presented by today's resource person, Dr.PSS.Srinivasan sir, the founder and the principal, Knowledge Institute of Technology, Salem. In his talk, Sir has emphasized the 7 key points that addresses the need of the hour in doing a quality research. The key takeaway points are as follows. Number 1, what is a research and understanding the objectives of the research. Sir emphasized on a scholar have an interest, they has to frame a timeline. They can follow a 60%, 30%, 10% approach, and they can spend 5 hours a week, and there has to be a perseverance in their research activity. Number 2, the research approach, the phenomenon of doing research. Number 3, the need of the research, the present need of the hour. Number 4, method of giving solution. The solution may be experimental, analytical, or simulation. Number 5, how to identify the research problem. That is the problem statement. Number 6, the heart of the research. That is how to handle and emphasize the results and discussion part with relevant to the examples. Number 7, the challenging part for the beginners, linking subject fundamentals and generating a variety of research problems. In addition, Sir has explained a sample research model on solar panel still that gives us a clear picture with high definition research inputs on a wider spectrum in different dimensions of research methodology, which pave the way for producing a quality research outcomes. Sir, we are all fortunate and admired by your structured research talks. The session is fabulous and really an eye-opening session for all young research scholars. We assure you, sir, that every one of us do a high-end quality research. Thank you, sir, for such a magnanimous research talk. I express my sincere thanks to the management of KOT Trust, Principal, Vice Principal, Director Placement, Director Training, CDT, Director KBSS of KOT, respective heads from distinguished departments, faculty members of KOT KBSS, technical support team, and faculty members and research scholars from other colleges and university to make this program a grand success. I extend my cordial thanks to the coordinator, Dr. C. Muliraj, head of the department EEE, and Dr. N. Sandhya Kumari, HOD, Department of ECE, and the organizing team of this research webinar series, Dr. P.A. Gauri Shankar, Assistant Professor EEE, and Professor Veerakumar, Assistant Professor ECE, for a well-structured planning and quality execution of this research webinar which paved the way for the real success. Once again, I thank all the well-wishers of KOT and KBSS and thank you for the opportunity given. Over to moderator, Dr. Mudira sir or Sandhya Kumari ma'am.
Thank you, Krishnan sir.
Thank you,
Now
sir.
the program is going to end.
Thank you very much.
Yeah, thanks to all.